Hi guys, so welcome back to our learning journey. Welcome back to the Python learning journey 100 days of Python challenge. Today is day 51. We are still on the course Introduction to Statistics in Python. But in today's lesson, we'll be starting on the last chapter of this Introduction to Statistics in Python, which is correlation. So we started all the way from chapter 1. So the whole challenge, the whole course or career in this Datacamp platform, the whole Python data analysis in Python career track actually has on 9 courses. Out of those 9 courses, we have some project that we need to work on to show and practice what we've been learning or we're learning so far in these courses. We are actually on the 7th course right now. We have a couple of course more to complete, then a couple of projects. So the 7th course we are on is the Introduction to Statistics in Python. We are on the last chapter, which is correlation and experimental design. So in this chapter, we'll be learning how to quantify the strength of a linear relationship between two variables and explore how confounding variables can affect the relationship between two other variables. I know all those may sound too technical, but probably when we start practicing one or two lessons, watching one or two lessons, and practicing one or two examples, you're going to understand how to measure correlation or relationship between two or more variables and what can't correlation measured. So I'll just go ahead and start sharing my screen. So welcome back to this challenge. So if you are new to this channel, you can go all the way to day 1 on the live on the channel, which is Excel Island YouTube channel, where you can just watch all we've learned so far from the Python basics from day 1 to introduction to Python, on list in Python, tuples, or probably pandas in Python, and the basics of Python that we've covered so far before we got to today, day 51. The goal is 100 days of learning. We are 50% above day 100. So today is just day 51, which is 51% out of 100 days of learning. Probably we'll be finishing this whole lesson before the 100 and also practicing. So I've done a couple of challenges in the past where we did Power BI challenge. The first one we did was the SQL challenge, which is SQL challenge. Then we went over to do Python challenge, and we are now on. We went over to do Power BI challenge rather, and right now we are on the Python learning challenge. So whatever, if you're trying to upskill yourself in SQL, Power BI, and Python, just go to the live stream tab on the channel. You're going to see a whole lot of lessons and exercise files, which is already linked under the YouTube description to also download those files and practice and hone your skills in this data analytics tool. So I'll just go ahead and start sharing my screen. Then we get started on the last chapter of this introduction to statistics in Python. So we're on the course Introduction to Statistics in Python. So if you go under tracks, career tracks, we've covered a lot. So I'll just go ahead and we start our last lesson here immediately. So if you notice, we covered from chapter 1 the summary of statistics. We did random numbers and probability. And we went over to do mode distribution and the central limit theorem. These are all highly technical stuff. It's not really that technical, but you have to know how to wrap your head around it to understand the concept being covered here. So we just start with this correlation and experimental design in Python. So welcome to the last chapter in this statistic introduction to statistics in Python. Probably be covering this lesson within the next 2-3 days live stream, probably on day 51 like this, 52, or probably day 53 or day 54, because some of the contents are kind of technical. You need to calm down and consume this lesson and make sure you understand it pretty well.
Welcome to the final chapter of the course, where we'll talk about correlation and experimental design. Before we dive in, let's talk about relationships between numeric variables. We can visualize these kinds of relationships with scatter plots. In this scatter plot, we can see the relationship between the total amount of sleep mammals get and the amount of REM sleep they get. The variable on the x-axis is called the explanatory or independent variable, and the variable on the y-axis is called the response or dependent variable. We can also examine relationships between two numeric variables using a number called the correlation coefficient. This is a number between -1 and 1, where the magnitude corresponds to the strength of the relationship between the variables, and the sign, positive or negative, corresponds to the direction of the relationship. Here's a scatter plot of two variables, x and y, that have a correlation coefficient of 0.99. Since the data points are closely clustered around a line, we can describe this as a near-perfect or very strong relationship. If we know what x is, we have a pretty good idea of what the value of y could be. Here, x and y have a correlation coefficient of 0.75, and the data points are a bit more spread out. In this plot, x and y have a correlation of 0.56 and are therefore moderately correlated. A correlation coefficient around 0.2 would be considered a weak relationship. When the correlation coefficient is close to 0, x and y have no relationship and the scatter plot looks completely random. This means that knowing the value of x doesn't tell us anything about the value of y. The sign of the correlation coefficient corresponds to the direction of the relationship. A positive correlation coefficient indicates that as x increases, y also increases. A negative correlation coefficient indicates that as x increases, y decreases. To visualize relationships between two variables, we can use a scatter plot. We'll use Seaborn, which is a plotting package built on top of Matplotlib. We import Seaborn as SNS, which is the alias commonly used for Seaborn. We create a scatterplot using sns.scatterplot, passing it the name of the variable for the x-axis, the name of the variable for the y-axis, as well as the msleep data frame to the data argument. Finally, we call plt.show. We can add a linear trend line to the scatterplot using Seaborn's lmplot function. It takes the same arguments as sns.scatterplot, but will set ci to none, so that there aren't any confidence interval margins around the line. Trend lines like this can be helpful to more easily see a relationship between two variables. To calculate the correlation coefficient between two series, we can use the .core method. If we want the correlation between the sleep total and sleep REM columns of msleep, we can take the sleep total column and call .core on it, passing in the other series we're interested in. Note that it doesn't matter which series the method is invoked on and which is passed in, since the correlation between x and y is the same thing as the correlation between y and x. There's more than one way to calculate correlation, but the method we've been using in this video is called the Pearson product moment correlation, which is also written as R. This is the most commonly used measure of correlation. Mathematically, it's calculated using this formula, where x and y bar are the means of x and y, and sigma x and sigma y are the standard deviations of x and y. The formula itself isn't important to memorize, but know that there are variations of this formula that measure correlation a bit differently, such as Kendall's tau and Spearman's rho, but those are beyond the scope of this course. Okay, time to practice calculating correlations.
So there's a popular saying that correlation doesn't equate causation. Because two or more variables correlate with each other, it doesn't literally mean that one causes the other to occur. So I kind of remember this from a couple of Excel courses I've taken in the past before. So let's look at guess the correlation. So let's continue from here. Let's see. I'm trying to zoom in a little bit or zoom out. Probably we just have to. Yeah, I think it's better like this. So guess the correlation. So on the right, use the scatter plot to determine what the correlation is between the variables x and y. Once you've guessed it correctly, use the new plot button to try out a few more scatter plots. When you are ready, answer the question below to continue to the next exercise. So which of the following statements is not true about correlation? Okay, let's see. So we should use the scatter plot to estimate what the correlation is between the variables x and y. So what are our variables? So this variable x and this variable y. Let me just switch up my camera real quickly. So this variable x and this is variable y for this. So if we change what's the correlation between x and y, -1, new plots. Do I have to change the button? If I click on new plots, I guess it's pretty far off. How about new plots? Okay. Okay, I have to guess the answer here, but let me look at the question. It says, if the correlation between x and y has a higher magnitude, the data points will be clustered closely around the line. Let me listen to that again. It says, if the correlation between x and y has a higher magnitude, the data points will be clustered closely around the line. So correlation can be written as how, that is correct. If x and y are negatively correlated, values of y decrease as the value of y increase. I think that's correct. Correlation cannot be zero. Of course, it can't be zero, but let's see. Now let's guess this that we need to guess. They say if the correlation between x and y has a higher magnitude, the data points will be clustered closely around the line. If you add a display line of trend, let's see. Can see the line. These are scattered, so there's not much correlation between these two variables. X and y are not closely correlated. But let's increase the magnitude. Let's see. So new plots. You can see. I'll probably go for this number one. It should be correct because we're increasing the magnitude. If I go ahead and increase the magnitude to probably 0.8, I call in a new plot. You can see. So they actually cluster together. Ooh. So we know that correlation cannot be zero. That's true. Let me submit this a little bit. Take another look at the plots. Probably I'll have to refresh the plots. Let's ask for a new plot. Okay. Spot on. When correlation is zero, that means there's no relationship between two variables and the points appear to be randomly scattered. So that's correct. But I'm giving this a new shot. Let's see. Let's ask for a new plot. So what's the correlation between x and y? This is minus 1. This is 0 to 1. Oh, I probably have changed the new plot. So I have to, okay, look at the plot. Okay. Hmm. This is minus 20, minus 5, 10, 15, 20. And this is 5, 10, 15. The correlation should be, let's see. Oh, okay. Okay, I'm going back a little bit. Oh, I click on new plot. I'm supposed to click on new plots. This is 10, 0 minus 10 is minus 15. Okay. Try again. I'm a little bit closer. Let's see. At the sign. Take another look at the sign of your guess. The sign of my guess. Hold up. Okay. Let me go back a little bit. Get warmer. Oh, okay, as the previous. That's interesting. So that's another stuff another day. You can actually calculate the correlation between two variables using the Python relationship, the core method. Let me just open my Jupyter notebook quick here. Then I go over to my file. So I have my these data sets all provided. You can follow the link underneath the description. You have access to all these practice files. that we're using here. So we've covered chapter 1, chapter 2, chapter 3. So I'll just go ahead and create a new notebook for chapter 4. So let's so I just want to import all the libraries I'll be using that we've covered so far. So this will now be correlation. Then chapter 4, I'll rename. So if I run this line of code, so this all well and good. So this data set that we'll be using, that we're going to be using, this word happiness food consumption that we used in chapter 4 is already linked under the YouTube description. So you can just download those resources there. So let's continue. Let's see what we need to do here. So relationship between variables. In this chapter, you'll be working with the data set word happiness. So we have access to the word happiness data here, you can see, for this chapter. So I'll just leave a link. There's a link under the YouTube description to download this word happiness data, the CSV, that we'll be using in our correlation uh, lesson. So the report scores various countries based on how happy people in the country are. It also ranks each country on various societal aspects such as social support, freedom, corruption, and others. The data set also includes the GDP per capita and life expectancy for each country. In this exercise, you will examine the relationship between a country's life expectancy and happiness score, both visually and quantitatively. A Seaborn as SNS, Matplotlib as PLT, Pandas as PD are loaded and the word happiness is available. I probably need to load Seaborn as SNS. If I check my variables that I've loaded here, my libraries, I think I have Seaborn here. I have Matplotlib already. I'll just say import Seaborn as SNS. So Seaborn is used for data visualization. Matplotlib is also used for data visualization. While Pandas and NumPy are used for data manipulation. I think all of these are used for statistics. That will be using for our statistics lesson so far. If I run the code one more time, I shouldn't get any error there. So we've covered a couple of libraries over the past 51 days of learning. So now let me just connect to this word happiness data set in my own Python environment here. So to do that, I'll just copy this line of code real quick, just to make things a little bit faster. And my happiness is named, this CSV file here is named wordhappiness.csv. I'll just change this to word happiness, word underscore happiness. So it's going to be word happiness. I'm going to rename this to word happiness. So if I call on word happiness, just to have a quick look at the data sets, I'll just call on word happiness right now. You can see the data. We have over 1,400 rows of data and just 9 columns of data. I'll just put that head here just to view the first 5 rows of the data set. So you can see we have the country, the social support score, the freedom score, the corruption score, generosity score, GDP per capita, life expectancy, and happiness score. Probably we're working with 1 or 2 variables. That means 1 or 2 columns. We can actually work with all the columns in the data set like that. So let's see what we need to do here. So if we see create a scatter plot of happiness score versus life expectancy without a trend line using Seaborn. So I'm going to say create a scatter plot using Seaborn. Hold up a minute there. I think we covered the line of code recently there. It's going to be SNS dot Let me just take a peep. So we want to create a total plot of happiness score versus life expectancy, which is these two variables here, happiness and life expectancy. Happiness dot scatter plot, open bracket. So my x-axis is going to be happiness score. Happiness score. Then my y-axis is going to be the life expectancy column. So that's all. Then we just write plt.show here. Plt.show. Let me just copy this. We run the code here and see what we have here. Oh, you see happiness score is not defined. Probably I didn't spell the happiness score pretty well. Let's give it a shot here. We have happiness, happiness. Just making sure I spell that correctly. Let's run the code. Let's see the error we're going to get. Happiness score is not defined. Happiness score. Oh, why is it not defined? It's not saying that column. Really? Okay. Oh, sorry. I have to put it in quotes. Oh, this was saying my x-axis should be life expectancy. Let's see. Oh, okay. Do I need to mention the data set there? So this also be my live, uh, let's call this. This also be my y-axis and this my x-axis. Then data should now be equal to, I don't need to mention the data set I'm using. Let me run this line of code again. Uh-oh, it's saying my y is not correct. It says the problem is that you have used the keyword argument y twice. Okay, I use y twice. Oh, sorry about that. Oh, wow. Why am I getting this error over and over again? Oh, okay, let's see. Why? Because I didn't mention the data equal to word happiness. Okay, let's see. Data equals to word happiness. Now let's run the code again. Oh, my plt.show is not covered. Wow. So I need to go write my line of code completely. Now let's give it a shot here one more time. And let's see what we have here. Well, I could see. You can see this is definitely, there's no much correlation between life expectancy and happiness in this scenario. They're actually too scattered. But let's continue though. So if you want to visualize two data points, variables, x is life expectancy, which is life expectancy here on the x-axis, and happiness is y-axis here. So we need to mention the data equals to word happiness that we have here. Okay, this data set here. So let's continue though. So you create a scatter plot of happiness versus life expectancy with a linear trend line using C1, setting CI to none. So all I need to do is just add CI to none here. Let me just go back here quick and copy this line of code. Hold up a minute, 1 second there. Yep, I'm back. So all I have to do is just copy this line of code and make use of it one more time. Then I need to add line of a trend line using C bond setting CI to none. I just have to add it to the last part there. CI is set to none. Let's see if this is going to work. Then plt dot show line number was not required in the unique line number was not unique in this data. Historical loading move to okay. CI to none. Maybe I didn't get the CI part of the code. Let me try it out in this. In my Jupyter notebook here. I'm looking at the error I'm going to be getting. Oh, you could see. Got an unexpected keyword CI, none. Oh, I didn't specify the CI pretty well then. Let's see. CI, none. I'm supposed to run this line of code. Let's see. With a trend line. Oh, I need to use another uh, method to create this trend line. Oh, SNS dot lm implots, not scatter plots. Oh, okay, let's see. So you could also use, I think you could also use rec plots. I'm seeing what else you could use here. Let's run this line of code and see. So my non, voila. So we solved the challenge there. Let me just copy this line of code. So to create a scatter plot without a trend line, you have to use another method. With one with a trend line, you have to use another method. Interesting. Look at the trend line that we have here. I think I saw another method here. Let me just create another one using another line of code called rec plots. Let's see. Let's see if this is going to work. It's worked also. So two different methods to create the same result, to arrive at the same results. This LM plot or this rec plot. Because the rec plot is a little bit different than this. Or am I mistaken? But let's continue though. Let's submit and see. Okay, based on the scatter plot, which is most likely the correlation between life expectancy and happiness score? Ooh, that's a good question. Mm, I'll go for 0.5, probably in the middle, probably 0.8 correlation, because you can see that they're actually more closely packed together than be scattered or far away from each other. Let's give it a shot. Oh, we nailed it. You can see we need it super because not even they are likely, they're actually more closer together. Looking at it, their correlation is more packed together, you can see, as opposed to being scattered or spread everywhere. Now let's see, calculate the correlation between life expectancy and happiness score. Save this as score. So to calculate the correlation between life expectancy and happiness score, so I'm going to use this method called I'm going to mention the columns first, and not that. It's going to be life expectancy dot score. Then this in a bracket, happiness score. Let's run the line of code and see. So life expectancy is not defined. Okay, I need to remove this square bracket we have here. Let's do it like this and see. Oh, dot score. Probably I need to put this in a bracket. Okay, let's try it again. Oh, why am I getting an error? I need to mention the data sets, the data points first. Oh, that was my mistake there. So it's going to be world happiness. Close the brackets. Dot score the word happiness in another bracket. Look at that. Okay. Word happiness. Rest on the line of code. Ooh. You have to put this my line of code in brackets correctly. I know that. This my variables in brackets. Oh, wrong timing. Who is that? You can see, so our correlation is 0.78. That's close to 0.8 that we got earlier. Interesting. Let's see. Now let's calculate same correlation in this my Jupyter notebook here. And we got 0.7802, which is close to 0.8 score. Interesting. So now let's move to the next challenge. Vibrant visualization, scatter plots with trend line between two variables. Interesting. So we've covered all about correlation in today's lesson. Let's see what we can learn today again. Let's see if we can take one more lesson. Just give me a second there. So we want to look at correlation or caveats. Let's see what we need to learn here. What can correlation measure? Okay, let's take one or two or more lessons. This correlation caveat, what can correlation measure? Transforming variables. Does sugar improve happiness? Co-founders. Ooh, I think we have a lot to cover here. I think we should just stop here for today and we continue from this correlation caveat. What can correlation measure? Transforming variables. Does sugar improve happiness? Or design of experiments and a little bit of more lesson. Yeah, we're just going to continue from here on day 52. We've covered a couple of lessons today. So on today's lesson, we look at uh what correlation is. We actually learn how to measure the correlation between two or more variables. So we created a scatter plot that showed us the correlation between happiness score and life expectancy for this our world happiness data sets. So we're just going to continue from here on day 52 and let's see what we can learn so far. Interesting. So we're going to complete this last part of introduction to statistics in Python on day 52, definitely. We also have a couple of few more lessons to cover. All right, so that'll be the live stream for today. So if you found this learning journey of Python interesting and fun, do what to give the video a thumbs up, hit that subscribe button on the YouTube channel, and I'll see you on day 52 live stream. Bye for now. Let's get back to work. Do have a wonderful rest of the day.